Welcome everyone to the third and final type of conic section, which is a hyperbola. So I'm sure you had some idea what a parabola looked like. You might have even known what an ellipse looked like. Hyperbolas are weird shapes. They almost look like two parabolas going away from each other. To give you an idea where this comes from, if you can imagine a cone, which is really two cones in your mind, if you were to cut straight down through here and look at the shape you have left, it would look like this. It would be like two parabolas facing away from each other. Okay? But let's talk about how to draw these things. Here's the formula. Notice it looks almost identical to the ellipse. The only difference here is the negative. In an ellipse, it's positive and it doesn't matter the order. Here, the order is going to matter. No matter which of these two numbers is bigger, whichever letter is in front, the positive one, that tells you which way the hyperbola is going to go. So if the x squared is first, your hyperbolas are going to go sideways. If the y squared is first, your hyperbolas are going to go up and down. Here's all the information you need to know. You can check this out in class. I'm going to go pretty quickly through it. It's very similar to the other ones. The vertices are the same things we did for the hyperbola or for the ellipse. The horizontal or the transverse axis just tells you how far apart the two hyperbolas are, or the two parts of the hyperbola. The asymptotes, it's always y equals, and it's a line, and it's plus or minus because we're going to have two of them. It's the b over the a. So which ones are the b and which ones are the a? Well, the b is always the y thing underneath y, and the a is always underneath x. Which makes sense because this number is your slope, so I want the y number over the x number. To find the foci this time, instead of subtracting a squared and b squared, I'm going to add them and then take the square root. Remember, I don't need to actually square the numbers here because they're already squared. Let's show you how to graph this thing. The first thing we're going to do is we're going to find the 4 points. Okay, so just like we did for an ellipse, we have 4 points. And then we made a circle or made an oval for an ellipse. But for this one, instead of making an oval from those 4 points, we're going to make a box. And then we're going to draw diagonals in that box. Those are going to be your asymptotes, so through the corners of the box. And then we're going to figure out whether it's going to go top and bottom or left and right. And you always look at the first thing here. It'll tell you which way you're going. Because x squared is the positive one, it's the first one. It means that these are going to be left and right. So I'm going to draw along the asymptote until I hit that point that I drew earlier, and then back along. And then the same thing over here. Let's try one. So when I look at this problem, I know it's probably going to be a hyperbola because I see a minus sign. But it's not equal to 1. I need it to be equal to 1. So I'm going to divide everything by 144. And if you do that, you get x squared minus 16, x squared over 16 minus y squared over 9 equals 1. So here's my formula. Pretend like this was an ellipse. That means the x on the x-axis, I'm going to go plus or minus 4. On the y-axis, I'm going to go plus or minus 3. If this was an ellipse and this was a plus sign, I would draw my ellipse in now. But because it's not, this is a hyperbola, I'm going to draw a box here. This box is not actually part of the graph. It's just there to help me draw this. And I'm going to draw my diagonals in here. Oh, that's really bad. Let's try that again. That's not the best either, but we'll go with it. So there are my diagonals. I drew the box based on the square root of this and the square root of this. And then I drew my diagonals in. So the question is it top and bottom or is it left and right? You always use whatever letter is in front. It's x, so it's going to be left and right. Come along this asymptote at this point. Go back out. Come along this asymptote at this point. Go back out. Okay, some things they're going to ask you for. They're going to ask you for the They're going to ask you for the length of the transverse axis. In other words, how far apart are the two hyperbola sections? And they're going to ask you for the asymptotes, and they're going to ask you for the foci. So, let's go back to this. How far apart are these two things? How far apart is the transverse axis? Well, I went 4 to the left and 4 to the right, so it's a total of 8 apart. The asymptotes are always y equals plus or minus the letter under the y and the letter under the x. So it's sloped, it's y over x. But it's not 9 over 16, because remember, these numbers are squared in the formula. So it's going to be 3 over 4, which makes sense. I mean, you can look, we went up 3 over 4, up 3 over 4, down 3 over 4, down 3 over 4. So there's your 2 asymptotes. The foci. The question is it an x value or a y value? Well, we know they're going to be on the x-axis. They're always in between, they're always out here. So I know it's going to be something, comma 0. In this case, c squared equals a squared plus b squared. So c squared equals 25. So c in this case equals plus or minus 5. So the foci are going to be at 5 and at negative 5. So that's a hyperbola. Treat it like you would an ellipse, but don't draw it as an oval, draw it as a box. Draw in your asymptotes and then sketch your curve. The transverse is just how far apart these two are. The asymptotes, y equals plus or minus the y number, square root, over the x number, square root. And the foci, make sure you're on the right axis, in this case the x-axis. So I'm going to put it as this, and it's the square root of this plus this. Here you can see all that written down. Okay, so remember you have 3 types of conic sections. Parabolas have 1 squared in them, either x squared or y squared. Ellipse has x squared and y squared, but they're added. Hyperbola has x squared and y squared, but they're subtracted. Next time we're going to talk about graphs that aren't in the middle. So we're going to transform them, we're going to solve them, we're going to write them in standard form.